Hello, can you all hear me? Is that about right? Okay, good. So, yes, this is the arm64 port for Debian and Ubuntu. Sadly, it's a little bit Ubuntu-y at the moment, but we'll come to that in a minute. From my point of view, it's sound difference. Um, uh, Josh has covered the theoretical side of an important part of this. I shall now cover the practical part and try not to repeat too much. Wow, remote thingy. So, just in case you don't know who I am, I suspect quite a lot of people here do. I've been doing free software stuff for a long time, and I'm Debian for a fair while now. And since I joined Linaro, I've been forced to do Ubuntu things as well, which actually turns out to have some advantages. There's some things that are quite a lot easier to get done in Ubuntu if Canonical actually want it doing, or at least quicker than in Debian. So, especially when Debian's in freeze. So, ARM64, I don't know, how many of you went to the Fedora ARM64 talk earlier? Hardly any, right? Yeah, we don't talk to those people. Terrible. If you'd been there, you would have had a lot of information about what ARM 64-bit architecture actually is and why you might care, and how it's all for servers and is very cool. I'm not going to cover any of that stuff. You're just supposed to know there's a new architecture, it's shiny, and we need to make it work. A little bit about what's involved with getting that done, the initial bootstrap that was done inside ARM, and the work we're now doing in public, and how far we've got with that. 64-bit ARM, that sounds like crazy talk. Why would you want that? I guess, again, Andrew spoke about that earlier. To a large degree, it's about servers and desktops and real computers. ARM is, most people have had anything to do with it in the last 10 years, it's kind of been about phones and routers and mobile stuff. But in fact, that's not always been true. There have always been, when I started getting involved with ARM, my desktop machine was one of these RISC PCs back in 1994. It went surprisingly fast for a 16 megahertz ARM. It's depressing how much your desktop hasn't really got any faster since then, despite astonishing increases in the numbers. And yeah, these days you can buy a nice little, oh, my slide's missing, isn't it? Never mind. It's a solid run cube, which is a cool little box that came out last year, which is a desktop machine. It's about this big. You plug a keyboard and monitor and a hard drive in, you've got a real desktop computer. You can run Debian or Ubuntu on it. Similarly for servers, much of the early ARM porting work was done by the Rebel people for the Netwinder, which was a network ARM box based on a strong ARM. And 10 years, 12 years down the line, we now have proper server-looking boxes to stick things in. That's the 32-bit one. 64-bit ones will be along any minute now, I'm assured. Nobody tells me anything about exactly when hardware is available, but I think it's fair to say that by the middle of this year, there should actually be something you can run things on. It probably won't work very well. Maybe by the end of this year, there'll be real stuff. Again, desktops, laptops aren't actually as new as you think they are. ARM ones, the Scion were a long way ahead of the game back in 2003 with the original netbook. They even tried to claim the term netbook recently after everyone else had used it a lot, and they obviously hadn't sold any. So we had Linux running on that back in 2004. Sadly, it never got released, but it was very cool. A bit slow. I think that was the main reason it never got released. And now we have shiny laptops like the Chromebooks just come out, which is very nice hardware. And you can't quite see the name. This is the Genesee hardware. So yeah, it's not all about mobiles. It never has been. Obviously, Debian particularly has never really been the world's finest mobile operating system. So we're quite interested in what you can do with real computers, and a whole load of ARM-based real computers are coming any minute now. So this is the history of ARM ports, just to keep track of all this. So the original port, again, basically what the Netwinder people did, is the old ABI for V3 architectures, which has since been discontinued. We don't care anymore. Nobody cares anymore. There was, we try not to mention it, a very short-lived big endian version of that, which was only because the Linksys slug had a big endian binary blob Ethernet driver, and it was much easier to build the whole of the rest of the operating system big endian than it was to solve the blob. And to be fair, they fixed the blob a year later so we could throw all that away. It now just exists in source to confuse people because they naturally think that ARM-EB must be the opposite of ARM-EL, but no, in fact, it's a completely different ABI. So since then, we had the new ABI, which was bootstrapped. It was actually bootstrapped in about 2006, but it wasn't until 2009 it got released. More recently, everybody's moved on to V7 architectures where you actually expect to have a floating point unit, which is what ARM-HF is about. So I'm in the audience who've done all the work over there, the joy of bootstrapping. And now we have ARM64 coming along any minute now, 64-bit, yet another instruction set architecture, although, to be honest, apart from the 64-bitness and the entirely new instruction set, from a 32-bit point of view, it looks extremely similar to the V7 stuff. Oh, this stupid name. So, from your point of view, ARM64, ARch64, and ARMv8 are all the same thing. You don't care. But ARM care, and they really don't want to call it ARM64. But the kernel people noticed that the name they did want to call it, ARch64, was a pretty stupid name. So the kernel people said, no, Vue sucks, and Debian's going to do the same. So, so we're calling it ARM64. Sadly, the Fedora people have called it ARch64 because they're all brown noses. So, which is a bit unfortunate, actually, because now, from a user's point of view, this essentially the same thing is going to have two different public names. But there you go. Another bit of nomenclature, just because we're talking about this subject, it's very confusing unless you do this for a living. Build architecture is the machine you're building on. The host architecture is not the host you're building on, is the machine you're building for. And target only applies when building compilers, is the code that is being generated. So when I say host, I mean the target architecture, as it were, i.e. the thing you're trying to build for. Blame the GNU people. It's all very sad. And the number of things where they've done it wrong, the kernel people have got it wrong. If you look at all the build stuff in the kernel, they use host where they mean build. Oh, really? It doesn't help anybody, but that's life. Josh already mentioned this. Bootstrapping is thought of as a very rare thing, always was, until we noticed that actually we do it every year. And it would be nice if it wasn't quite so hard. So, okay, as I say, once ARM64 is done, I suddenly don't care anymore. And it's in some ways nice and in others slightly unfortunate that Linaro doesn't care anymore starting about now because we've got something that works using Open Embedded. So I've been doing this for a long time and they've been paying for that and that's very nice, but they quite like me to stop doing this and do something more useful. So I'm trying to get as much of this done before I really have got to stop.
So you won't be working on bootstrapping the ARM64?
Yeah, well, there is that, yeah. Or possibly the X32 equivalent for ARM, which will no doubt be along in a couple of years. Just watch. That's true, exactly. But that was probably relatively easy to bootstrap. Yeah, so bootstrapping is a pain because of build dependency loops. Now, Josh already showed you basically why this works, but I'm quite pleased with this little thing, so I'm going to show you anyway because it's shiny. So yeah, that is a typical loop from a while ago, but you know, it involves about 20 packages. I think the green ones are source and the white ones are binaries. Go on, do something. Yeah, doesn't work so well if it doesn't. There we go. So yeah, in order to build this, you want to build Poplar, but you can't build Poplar without installing that, which comes from the Qt, and you can't install that until you build this, which comes from libirdbc, and you can't build that unless you install libgtk2, and you can't build that until you build cups, which gets you back to Poplar, and you go, bollocks. So, yeah, and you think, why do I need some of these things? So the point is that Debian is maximally configured. You know, we turn everything on that's sensible, and there's a lot of language bindings. So there's all sorts of reasons why a whole load of stuff is needed, which isn't really needed. It's just sensible for a binary distribution. But that's exactly the opposite of what you want when you're starting off from nothing. So that's why this problem is basically not really a big problem in open embedded and build root and base rock and all sorts of sensible built from source every time distributions. But if you've got a binary distro where people expect to have their stuff already built with everything turned on so it works, the bootstrapping is awkward. So, as has already been explained, the process for the last ages has basically been build an image you can build on with something else, such as buildroot or OE. I think it's been OE generally for the last 2 or 3 ports, for ARM stuff at least. And then just sort of bodge and hack and turn things off until you can build stuff. Now, in the arm64 case, we haven't even got that option because there isn't any hardware. There's nothing to run it on, so we can't try and natively build it all from something. We have got models, which since October, but they're impressively slow. It's a 10 megahertz-ish sort of machine, I think, is the kind of thing you get. Well, it's not slow, but it would take a long time to build all the Debian on one. Yeah, there's M68K people, they know. So it would be nice if we could do this a bit more organizedly and automatedly and repeatably and so on. So clearly you have to cross-build some of your stuff. You've got nothing, at the very least. First, you've got to get yourself a toolchain, and then you've got to get enough of an image that you could install that and build some stuff natively. Now, how much you do cross before you switch to native is up to you. You could build the entire distro cross if you wanted to, or you could build as little as possible. We'll come on to how much that is in a bit, about 100 packages, a couple hundred, and everything else native or anything in between, whatever seems expedient. And in order to do that, you have to be able to linearize the dependencies. So we need to do some cross-building. How are we going to do cross-building? So for a long time, so the 2 basic problems are your cross-dependencies and then actually making builds work. So we have various tools to try and work out whether a dependency was a cross-dependency or a native dependency. So obviously, basically libraries, you need the host architecture version, whereas all the utilities, make and stuff, you just want the build architecture version. It just has to run. And we have various tools for trying to decide which of these you needed, or just installing both always and hoping that worked. And dpackage cross, which has been around for over a decade, I think, which is basically a tool for munging the paths you install things on so that you can install both a native version and a cross version somewhere else. So they paths, historically, libraries used to go in user triplet, libraries and headers, which is fine, except that the path you're building against is different from the path you're finally going to install to, which makes your builds complicated and wrong and broken and gives libtool endless opportunities to screw it up. So the nice thing about multi-arch, so having done multi-arch for an entirely different reason, which was basically co-installability of 32 and 64-bit libraries for x86, was really the driving force. Pretty much for free, you get the ability to co-install libraries for different architectures and headers for different architectures, and you almost get the cross-dependencies defined for you. If you can co-install it, then it was probably something you wanted to cross-depend on. And basically, you just have to mark up the cases where that's not true. And the really cool bit is that the paths don't change now from when you're building and when you're installing and when you're running. There's just the path. Everything becomes canonical. And this is really, really nice. I've become a huge fan over the last year of actually using this. It's really rather nice. And you don't have special packages for cross-building either. The normal packages install in the normal paths, and everything just is. And the other thing we need is this profile concept, which is fundamentally pretty simple. It's not anything very clever. It's just saying that when I want to build this package, I want to be able to do it without libsqldev, because that's optional. So if I specified the stage 1 profile, then not this package. That's it. Now, in fact, the syntax is going to change, it turns out, almost certainly to square brackets instead of angle brackets, but meh. And then in your rules file, obviously you can do arbitrarily complicated things, but in most cases it's something fairly simple that says if you set the build profile to this, then don't bother building that package, and configure turns off this feature. And that's the sort of genius work we do. So a little bit more detail on multi-arch for people who haven't seen me witter on about this several times already. It used to be that libraries were just installed to use a lib, and if you wanted, for each architecture, it always went to the same place. So you couldn't co-install them because the names clashed. You could only have one. So by putting an architecture qualifier in, so it's user lib triplet, you can now install them side by side. Fundamentally, that's it. So you refer to packages with a package name : architecture qualifier. As I've already said, the file names don't change. It means you can easily run things in place with QEMU if you want to just install stuff. If you've got an emulator, it can run it. If it's something which will already run on the CPU you've got, it'll just run. So we sort of had this for years with lib64 and lib, but that was a really sort of cheap crap version which only did 32-bit and 64-bit. So, for example, if you wanted ARM64 and x86-64 stuff for some reason, couldn't do that. In multi-arch you can. You can have any arbitrary combination of things, and it should just work. The big catch, under some circumstances, is that your versions must stay the same. You can only install the same version of this library for each architecture. You can't install a different version for a different architecture in the same file system. If you want to do that, you need to put it in a chroot. For a binary distro where we build everything, that doesn't really matter. We do that anyway. It can be slightly awkward during the bootstrap process and in some other circumstances where you wanted to build the latest of everything. You didn't want to build it against the distro versions. So you add an architecture by saying dpackage add architecture blah, and apt-get install package architecture name. It's very simple to use. This is the other half, which is the multi-arch specification saying which things are co-installable and which things aren't. Basically, we distinguish between libraries which are co-installable and tools where you don't care which architecture it was as long as it runs. And we also have allowed for things which could be either depending on how you want to use it. In practice, that's turned out to be not very useful. It's usually easier to split the package into two halves, into the tool half and the library half, and specify as one of the others. But we do have a few things. Most notably, Perl at the moment is allowed. And then that is from the point of view of whether the thing is co-installable. It doesn't necessarily tell you whether the thing depending on it wants the same architecture or a different architecture. Usually it wants the same, but just occasionally a build will need the build architecture version of a library, not the host architecture version, or it'll need both, which is why we have these modifiers, any and native, which allow you to basically to mark up the exceptions. I'm going this relatively fast because I've already given that talk once, and there's a fair amount to say. So here's an example, just in case this isn't making sense to anyone yet. So for the slang package, that's its normal set of build dependencies. And basically, you want these four. You want the ARM64 version of, and all those other tools at the top. You want the build architecture, usually x86, AMD64 version of, because you just want them to run. And as you can see, it's not obvious from the package names which it is. So we used to have heuristics, like if it ends in -dev, then it's probably a cross thing, right? Oh, except for dpackage dev and autotools dev, actually, because they're different. And similarly, if it begins with lib, we probably wanted a cross version. Oh, except libtool. And so that is what xdeb is. It's just a great list of the thing and all the exceptions. It does a surprisingly good job under the circumstances. So the whole thing about this is that it's nice and neat and actually works properly. And yeah, so here you are. You can just install stuff and cross stuff, and you get your build dependencies. So yes, we've already done a bootstrap. Did it about nearly 2 years ago now, inside ARM when Maverick was cool and trendy, which used xdeb because the multi-arch stuff was way too immature at that point. We didn't have a proper package toolchain. We just had a magic binary tarball, which was the existing ARch64 cross toolchain. And the problem with that is that you'll find you can't install all sorts of things because everything depends on libc6 or libgcc or libc++. So we had fake dependencies for all those things which the toolchain actually supplies, but we didn't have real packaged binaries of. And by a lot of hacking, making things cross-build, taking out the bits you didn't need, so doing all this profile stuff manually by just chopping it out, and working out what order you could actually build it in and writing some evil scripts. They built a root file system good enough to send to people to get started on early arm64 work. So, so this is cool. So it's done already. Marvelous. We haven't got any work to do. What's the problem? Well, the problem is that ARM is an imaginary property company. So I asked how rude I was allowed to be about the legal department, and to their credit, they said so long as I pointed out that ARM was an IP company first, I could say whatever I liked. So so the problem here is that we have all these patches for stuff which basically aren't very exciting, making random packages cross-build, and legal wouldn't let the people who'd done it send it to anyone. And you go, well, why not? The thing is that most FLOSS licenses grant a patent license to the code, and they don't just grant a patent license for the 4 lines you added. They grant a patent license to anything you might want to do with this entire code base ever. So legal go, it does what? You want to send a patch to SSH to make it cross-build. That means we have to grant a patent license for everything we ever did to anything anyone would ever want to do with SSH ever. That sounds a bit scary. We'll have to look at that. And basically, they're busy and decided that they couldn't be bothered looking at that enough to actually enable people to send the code in. So all this work was done, but they weren't allowed to send it to anyone. And the problem is, from legal's point of view, this isn't even that unreasonable. You know, it would be a lot of work to check, even though it's obviously not a big deal. So anyway, we've got to do it again properly. So this this is the scary stuff that couldn't be allowed out. You know, if cross-building, set cross for like 50 packages. But you know, checking that doesn't that the package you put that in doesn't conflict with any of your patent licenses for anything ever is actually very difficult. So such is life. So on the one hand, they used all the community stuff. They did it using upstream methods and the latest thingy. They asked me, more or less, you know, how should we do this? And did what I said, which was nice. But then they were entirely unable to contribute the work they'd done, which is a bit crap. But it pretty much illustrates the problem Linaro has generally. Linaro tries to work in the open, and we work with these great big corporates who fundamentally want to do everything behind closed doors so they can make big marketing announcements. And it's a continuous struggle dealing with that culture clash. So, the actual Bootstrap. Yeah, so I wanted to do this in Debian because, well, it's just better, isn't it? But well, more to the point, I'd have to file every patch twice. That's the main incentive from my point of view. But unfortunately, when this really got going kind of middle of last year, we'd just about frozen. So a lot of multi-arch patches weren't in Debian and were already in Ubuntu. So it was a hell of a lot easier to... so I used Quantal for a while, mostly because it wasn't changing all the time. And at some point, that became painful and more things were fixed in raring. So we moved over kind of end of November, I guess. So this time, everything was done in public, upstream as we go along. Oh yeah, so one thing I should possibly not mention is that I'm actually able to read the repository containing all these things. So some of the patches I've submitted may be surprisingly similar to the stuff that wasn't upstreamed. But I have a number of hats, and the convenience of changing them can be quite useful sometimes. To be fair, nearly all of it was that exciting, so it's not a big deal. So we use multi-arch this time because it's ready enough. Various things are still broken, but it's actually pretty good. And all the standard tools. So rather than having a special tool for installing cross dependencies, you just use apt, and you just use dpackage to build things. We still have dpackage cross, but not for its ability to munge packages, but because it keeps the autoconf cache data for things which you can't, cache settings that you can't discover without running a program. So we just write down the answers and say use those. And reprepro for the repository, and sbuild. I taught it about cross-building, and so this is really nice. You now cross-build things the same way you natively build them. Actually, that's probably another slide. We added profile support, and this useful invention, which we should have done years ago, for cross-build essentials. So basically, that's just a meta package to install across toolchain, a C library of the host architecture, and a cross version of package config, which is a link. Partly because I think it's a good thing generally, but also because there is no QEMU for arm64. I was keen to avoid anything which required QEMU to run random scripts. Now, a lot of crossing gets a bit easier if you've got a QEMU, because every time you randomly run something with the wrong architecture, it's quite likely to still work. But we don't have that luxury for arm64. So the process is fairly straightforward. You need to prepare a local Bootstrap repository for putting your hacked and bodged stuff into. Or indeed your perfect and absolutely correct stuff, but there still isn't anywhere in the mothership distribution yet to put things, so you need a repo. Dpackage is the thing that tracks new architectures. You just add the new architecture to a table, and then everything that does anything about architecture stuff always asks dpackage architecture, which knows about the mapping between GNU names and Debian names and kernel names and any other names we might need. Set up a chroot. Make your toolchain work, painful part. Sort out, make sure that dpackage cross has autoconf variables for your new target architecture. You've got a cross build essential package listing the new toolchain packages, and importantly, autoconf has config.sub and guess files with the new architecture in, so that everything can find it. Isn't that the same thing? Configure. Autoconf is GNU config. And then build stuff. So how much stuff exactly? Well, Josh showed you approximately how much stuff. These are some numbers from a while ago, but as far as I can tell, they're still almost exactly right. So on my table of finished and not finished things, there's 65 source packages and 12 source packages which only produce architecture all binaries, i.e. 77 source packages in total, which need to be built, and only 65 of those for the target architecture. That is to make a, well, that's the set of packages which actually end up in a chroot with build essential in it. You actually need to build quite a few more. That's where the 140 odd number comes from, for all the things which those depended on in order to be built. So as far as I can tell, around about 140 packages gets you a image. I've built 128 so far. Toolchain. This is the classic three-stage bootstrap for toolchain. You need a set of Linux headers for the new architecture, a really basic C compiler you can build against that. That enables you to build a really stupid libc. Then you can build a C compiler that actually knows about the libc. And then you can build a proper libc, apart from the SE Linux part. You haven't got that yet. And then you can build a full version of GCC. This has always been fun and games. It's currently, that process is automated by a cross-toolchain base package, which is largely Marcin's. Yeah, okay. I've got hecklers. I believe this can be munged into the profile mechanism so that you don't actually need a third-party package running the build process. But I haven't quite got it working yet, so that's how it's been done. So the way that works is, in order for that package to depend on the stuff it needs, there need to be binary source packages of the sources you need. So there's a Linux source, a binutil source, an eglibc source, and a GCC source, which are installed, munged a bit, patched a bit, and then built through that three-stage bootstrap. It's always awkward for a new architecture. For the reasons will always vary for your given bootstrap case. You know, in this case, the arm64 support that ARM had done was against kernel 3.7, whereas the kernel in Quantal that I was building against at the time was 3.5. And you go, nah. But it turns out, actually, all you're trying to do is make the headers package, and it's really not that fussy about the details. So as long as you can get a Linux source package out of it, 90% of the stuff, it doesn't matter whether the kernel works or any of that rubbish, you just need to get headers package out with some stuff for the right architecture. So it's a bit of fiddling, but it's really not very problematic. Worse was eglibc, which, again, the support was done for eglibc 2.16, but the version in the distro is 2.15, or if you're doing it in Debian, 2.13. and that is kind of painful. But it turned out that the 2.17 support was inexperimental in a Git repo somewhere. So actually I was able to, sorry, the 2.16 was inexperimental, and I was able to take that and apply the patches and kick it a bit and get it to work. Except that only builds with GCC 4.6. And you haven't got a GCC 4.6, you've only got a GCC 4.7. So you have to find out whatever the obscure reason is why it didn't work with 4.7 had therefore been specifically set to not use it. I've forgotten now, but I got it going eventually. So there will always be a certain amount of dicking about like that for new architecture. It's annoying. It's not helped by the fact that the GCC and eglibc packaging in Debian and Ubuntu caters for Debian and Ubuntu and Linaro, and 12 architectures and a couple of operating systems. So it's not really one source package. It's like 17 packages all munged into the most amazing patch set. Docker's a pretty scary guy. So you have to understand how all that works before you do anything. Setting up a chroot is essentially trivial. If you go to this web page, it will tell you what to do. You install sbuild and type sbuild create chroot, a path, a distro name, and that's it. And it'll make you, so that's just an x86 chroot for your build architecture, in which you can install cross-build essential and carry on. For arm64 and generally any new architecture, there'll be some bits missing. So in this case, there is no libssp and therefore stack protection, so you have to turn that off. But that's okay. We have depackaged build flags these days, which is really nice. And everything I've used, about one package out of 100 and something, didn't use it. So you just you tell depackaged build flags to nobble that flag every time anyone gives it in your chroot, and it just works. It's great. For the initial toolchain, the library search path was wrong as well. So we had a library search path nobbler in here, which also worked pretty well. The only problem with that is that it always applies. So you can build everything except packages which need to also build some build architecture tools. At that point, they get given the host architecture path and it all falls over and dies. So you can't do things where you've got to build for both architectures without having a toolchain that actually uses the right paths. But that got us quite a long way. Also, you want to tell the system to prefer the packages from your Bootstrap repository, which have profile builds and things, so that you don't get the wrong source. So cross-building is now very simple. You apt-get install cross-build essential architecture name, then you apt-get build dependencies -a architecture for whatever package you want to build. And assuming the multi-arch foo is all correct, which for a large number of things now it is, I think in raring you can now build 496 packages out of 1,200 just by doing that. That's pretty good. Change into the package and run depackage build package -a architecture. So cross-building is now almost the same. It's congruent with normal building. It's really quite nice. Now, in practice, this will not work quite a lot of the time, because, for example, as soon as it runs the checks, it'll all fall over. So you always want to run with deb build options equals no check. Now, we could have put that in depackage build package, but we can conceive of circumstances where you might actually want to run the test even though you're cross-building. For example, if you've got an emulated environment, or in fact if your tests aren't architecture dependent. So we left that as something which you can still enable if you need it. Similarly, you need to tell autoconf, if it's an autoconf package, to go and use the autoconf magic runes to set it up. So in practice, you always type this. And that's a bit dull, so actually you just, sbuild does both of those things automatically. So you just do sbuild, blah, gone off the bottom, but that says --host equals architecture name. So sbuild will basically do all this for you. And that's very nice. If you want to do a profile build, you set dead build profile before running depackage build package, or you can use a -p option now. Now this stuff is not yet in the main, everything so far is in the main distro. This isn't yet, because we're still arguing about the syntax. But if you use my Bootstrap repository, there's versions that do these things, or the Linaro cross toolchain bucket. As of last week, Josh wrote a very handy patch to apt, so that apt now understands a build profile option. I'm glad he did that because I looked at the code and went, oh my God, I don't understand C++ at all. It's a complete mystery to me. Even after someone had told me which file it was and which function it was, they said, this is the bit you need to change. And you go, no, I really don't know what to do. Can we find someone cleverer, please? So yeah, so this is very nice. And sbuild will pass on a profile, which means these two things happen. And I got a bit bored of typing all this stuff after a while, so I've written a very stupid script called dimstrap, which just closes the loop of updating from source, building something, signing it, uploading it, running rep repro process incoming, and then doing the next package. Because the way this works, generally you're building something because you need it as a build dependency for the next thing. So you've got to put something back into an apt repo each time before you build the next thing. So yeah, here's my little chart of, this is actually the cross-build daemon we were running for an existing architecture, where you're much more likely to already have the build dependencies. But in fact, it's exactly the same process for dimstrap, except that it's not a daemon. You just type dimstrap package name or give it a list. So this works for everything except where the multi-arch dependency, the apt-get build-dep -a architecture step fails, which is still true for quite a lot of things, especially anything that needs Perl. These are just the runes you type to do a dependency analysis using those deb build check, which is Josh's tools. So you basically say use these source repositories and binary repositories, well, binary package files, in fact, and a source file listing the sources you care about, and then you can get it to give you an enormous list of all of these packages, and it will just say whether it's currently buildable or not, whether its build dependencies and its installed dependencies are available, or you can just run it for one package with -check only, which will say, can I build this? And you get a little thing saying, no, you can't build it because you haven't got that yet. Now, in practice, you don't need to do this theoretical analysis much for the chroot step because it's such a short list. You can just try building it, see what went wrong, which is how I've actually done most of the work. Now, we might have a window in here. Here we are. So, in fact, this is the output of running effectively sbuild on all of these things. So, except for the ones that say manual build, that was when sbuild would have failed to install the dependencies, but I could install them manually and then carry on. And as you can see, this has gone pleasingly green over the last couple of months, and we're down to about 5 things that haven't built. Now, we don't actually know whether they work or not, but that's a different problem. So this is the set of build dependencies that I had to nobble in order to build the 65 binary source packages, 65 binary producing source packages for arm64 Bootstrap. So eglibc these days wants libse Linux. I think it wants lib something else as well, actually, which obviously you haven't got to start with. So this shows you, this is what most profiles are about. It's generally language bindings. So, Swig and Ruby bindings for libse Linux, which obviously are things you really don't care about at this stage. And similarly, Python bindings for things like cracklib Python bindings, dbus Python bindings, and so on. Java bindings, joy. Dbus is a bit fiddly, the whole dbus glib thing. In fact, I was pleased to find that if you look in the packaging for this, there's a whole lot of comments saying, if you need to bootstrap this, just nobble these 4. And you go, wow. And a few things, I think libse Linux already had staging information in it. It's great. So, and during this process, Canonical have actually done quite a lot of work on cross-building armhf. So a whole load of things got fixed in the last few months, so that the package does in fact cross-build, which means that I can expect it to work in the arm64 case as well. So anyway, that's the set of stuff you need to change in the base things, i.e. not that many, and often in fairly simple ways. So, how far have we got? As I say, because of the Debian freeze and the kind of 200 pending multi-arch bugs, it was much easier to do this in Ubuntu. So that status that I've all been talking about is basically the raring status. Cross toolchain is available to install, and it works, and the cross support stuff exists. As I say, if you want the profile support, you need my special repository. We have basically done the work of multi-arching Perl and Python. Python, as far as I can tell, works. Perl, there's been a very abstruse argument on the Perl mailing list about whether it's actually right or not for all conceivable cases of Perl API changes as you upgrade things from one Perl API to another. And to be honest, I don't actually understand the argument anymore. I don't know whether we're finished or not. It seems to work from my point of view, except that because Perl is allowed, you have to say Perl:any all over the place in packages that depend on it, which is boring but simple. We haven't done very many of those, which is why quite a few things need a little tweak to actually build. So the question was, is there a plan to make Perl not allowed? There is a thread on the Perl mailing list, which is a very abstruse argument about exactly how it should be multi-arched and split up. And it's not entirely clear what the final outcome of that will be. I think we need to use it for a bit and see whether anything's broken about what's been done. It appears to work. I managed to build an XS package, and you can build normal stuff, and you just need to specify :any to install things. As far as I can tell, that's sufficient. I guess we're going with that for now, and if we find there's a problem later, we'll have to change things. Obviously, the architecture all packages we basically don't have to worry about because we can use other architectures that already got built. As I said, we've got 128 source packages built for ARM64 and 72 of the 77 that I need to install to make Chroot built. So yeah, I reckon there's about 10 more packages to do. I was hoping to get it done for now so I could show you a demo and go, it's done. But meh. I blamed DB, which was a pain in the arse. It took about a week. So the only thing is, right, I've built stuff. I'm a build engineer, right? I haven't run any of this. It's probably all wrong. Not least, it's built with libc 2.16 early, and we've discovered that there's some fairly serious breakage in there. So we almost certainly need to rebuild it with 2.17 anyway. With all the multi-arch foo, that is just a manner of doing dimstrap list of packages. Or we can almost, script a rebuild now, which is quite nice. Well, we can script a rebuild. The script's probably not quite as short as we'd like. Yes. So yeah, those are the things that are still left. So I'm just trying to get Perl to cross-build. So thanks to Neil's fine work over there, there's now a helper package, Debian Perl cross, I think. Perl cross Debian, which basically keeps the enormous config foo files which Perl uses to work out how it should cross itself. And I've made one of those, but it didn't actually build for some tedious reason. I don't think that'll take long. GNU-pug needed something or other. So this is really handy because you just go and look and go. So it needs LDAP. So I'm pretty sure that's an optional feature of GNU-PG. So we'll just add a profile to say, no, I don't want LDAP, and that should be done. Plymouth's a bit of a pain because it wants Cairo, which wants libfreetype, which wants libfontconfig, which wants libxcb, which wants libx11. I got quite sure of the order in there, but I don't want all that crap. So I'm pretty sure we can turn off the X feature of Plymouth, at which point it should get rather easier to build. You could just not install this as well. Yeah, I think there's some problem there though. Does that actually work? Yeah, I think you'll find your Ubuntu will stop waiting for Plymouth to display something. You could probably kick it in the head, yes. Yes, we could. So yeah, you could almost certainly make, you don't need GNU-pug to boot either. So you could already make an image from the packages we got and see whether it works with a little bit of jiggery-pokery. Yeah. What else is of note here? So yeah, one thing that's quite tiresome bootstrapping against a moving architecture like unstable or currently raring is that cross-build essential expects to have the matching version of libgcc and Linux libc dev and libc of the build architecture. So every time someone uploads a new glibc or a new gcc or a new kernel, suddenly you can't build anything because cross-build essential won't install. And you go, "Oh!" And you have to go back and rebuild those packages. Now, that's trivial for the kernel headers. It's trivial for the kernel headers. And it's not too bad for the GCC stuff. That seems to be okay. But it's a bit of a pain for eglibc. So, for example, we just had a new eglibc 2.17. Great. I wanted one of those. Doesn't cross-build, does it? So I'm currently screwed and can't build anything until I've fixed that. And that was because it only actually builds because there's some patches in the cross-base toolchain foo, which should be upstream in the main thing. So it is a bit of a pain, that tracking feature. Obviously, in a release distro, this doesn't apply. And it hasn't caused me much aggravation. It's just every so often you notice that everything failed today. The one thing we've realized is missing from all this beautiful technology is when packages specify an explicit dependency on something in a toolchain, like GCC 4.6 that eglibc needed, nothing in the system says, "Oh, actually, we're cross-building." You actually mean cross GCC 4.6. So it just says, "I can't install GCC 4.6 colon arm64. Nah, I give up." So we need a mechanism for that. And we have a plan. Colin Watson schemed one up. But that will delay all this being totally beautiful and finished for a little while. The other thing, there are things further up the tree which are going to cause us pain. Object introspection is used a lot in the whole GNOME foo tree. And certainly for Maverick, you get away with just turning it off everywhere, and it still worked. I suspect that's not true anymore. And the only way to make it work is actually to write a cross object introspector, which will know what to do. So we'll hit that at some point. But we don't have to do that in order to get to a native machine. So we'll have enough to make a build image which we could put on real hardware and then just build everything natively. So you don't need that, but you would need that to be able to cross more things, which is probably useful. Just a little observation of this bootstrap, partly because a lot of this is new. You know, Debian never really worried much about cross-building, and the multi-arch stuff is new. Most of the work is not in ARM64 specific things.
So how far are we now from having enough packages to run the bootstrap?
3. 4. 4, I guess, actually. Depends whether you kick Plymouth in the head.
Okay, that would be nice to publish when that happens, so people can actually try it and have a Debian CH root available.
An Ubuntu CH root.
Ubuntu.
We're about 65 packages away from a Debian CH root. So yeah, it is very nearly done, I think. You never quite know until you've actually finished how many more things there are. Like I say, Plymouth sort of implies at least 10 more things, some of which I know don't work. Pretty much out of time, but that's okay. We're about done. Yeah, so you can already run ARM64 stuff using the open embedded image, which Lenara's released. So that works. If you only need to run stuff or you want to try your stuff, that's fine. But obviously, if you want a real distro, then helping fix cross failures is a jolly good thing. There's a raring list, and there's a raring ARMHF list that Canonical's now maintaining, and there's my ARM64 list, and there's URLs here. And that's it. Pretty much used up all my time. Is there anything anyone has a burning desire to know?
Just on that, on the Perl stuff, it is probably just we'd need to calculate some of the values that ARM64 needs to provide for Perl, which we haven't actually done because they're not needed for autoconf or anything else yet. They are Perl specific.
Indeed. So I copied the another 64-bit architectures list and then put a few ARM things in.
Yeah,
and
and
there's
then
also
it
the
went
open
bang.
embedded version, which we can compare with. So yeah, I've got a file which might be correct. It's actually it for one define, it stripped the hash off the beginning and then said, "I don't understand define," and barfed. Is that the...
Yeah, that's because of the same problem. Is you actually need to have there's a version lock in
Right.
the config file, so you've got to make sure you start with the right version in the first place. You can't use files from old versions.
Right. Yeah, I spent 4 hours rearranging the order of all the things because they come out completely different from different Perl versions for no good reason. So when you try and diff your file, you go, oh, it's totally different. But it turns out, in fact, it's almost exactly the same in a different order. Hateful, hateful thing. I think I should probably stop unless there's anything important. Thank you very much.